Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is the second part of the harder version of the solving radical equations worksheet. So if you wanted to see the first part, that's in the other video. It'll be part 2A. This is going to be part 2B. So go check that out. I might have that in the description, but I'll definitely have it in the playlist. That will be at the end of the video at the very least. So check that out if you haven't seen that yet. This is the second part, and we're jumping right in where we left off with number 15. We have the square root by itself on the left-hand side, and if that is the case, then you can just start off by squaring both sides. So negative 45, 14n, n squared. Now we have an n squared and an n. Anytime you have two different powers or more of the variable, the only way to go from there really is to factor it. And in order to factor it, we first want to get it set equal to 0. So we're going to set it equal to 0, which means we'd have to subtract n. But actually, you know what? It'd probably be better, it would make more sense if I actually get rid of the stuff on the left-hand side, move it over. That way my n squared is positive. So 0 n squared, I'd have to subtract 14n on both sides, add 45 on both sides. And then from there, I want to factor. So I want two things that multiply to 45. How about 5 and 9? Yeah, that adds up to 14, except we need it to be negative, so we need both of them to be negative. Set that equal to 0, which means, and I need to zoom in a little bit here so I can squeeze in a little bit more work, which means that we're basically already done. N is going to be equal to 5 and 9. Now we just want to check to make sure that they both work. It looks like they should because they're both positives. If we got a negative, that wouldn't work because a square root would not be able to be equal to a negative number. And it looks like that works out. That'd be 70 minus 30. Let's see, 70, 25. Yeah, so that would work. And then for the 9, that's 14, 36, 9, 1, 2. Minus that. Should be 81. Yeah. Yeah. And then square root of 81 is 9. Yeah, so they both work out. And of course, I don't have space to write those out. But if you wanted to, maybe if it was a quiz or a test, definitely on a test, I would check them by plugging them back in. On a quiz, I don't know, it just depends on how strict it's going to be graded and how much time you have, I guess, too. So, same thing for number 16. So x squared equals 110 minus x. Let's get everything on the left-hand side. So I'd be adding x to both sides, subtracting 110. That's going to be set equal to 0. So that's 10 and 11. Multiplied to 110, we need that to be minus, that to be plus. So that way we get 1. So we get two answers here. We get x equals 10 or negative 11. And just like I was saying on number 15, if I plug in negative 11 in here, I don't even need to check the math really because I'm going to have to take a square root at some point. And a square root can only be equal to a positive number, assuming real solutions. So if a square root can only be equal to a positive number, then negative 11 won't work right off the bat. Now, sometimes negative numbers do work for radical equations, but when it's set equal to a variable like that, the way it's set up right here, that negative is never going to work out in this particular scenario. So that just leaves us with 10, and 10 works out just fine. All right, so 17, square both sides. 9n equal to n squared. And we'll do the same thing. We have two different kinds of n, so we still want to get everything to one side, set it equal to 0, except now we don't need to do trinomial factoring. We just need to do a little bit of factoring, some GCF factoring. I'm going to take out an n. They both have n in common, so I factor out the GCF of n, and that leaves me with the solutions of 0 and 9, and both work. And we talked about that a little bit last time. Whenever you have a square root equal to an n like that, then the solutions are always going to be 0 and the number under the radical. We talked about that a little bit last time, but that's the only one that came up, I think, on this worksheet because the rest of them get a little harder as we go here. Okay, moving on. square, square. And if I'm moving a little bit fast, it's just because I'm on a little bit of a time crunch today. But I also went a lot slower last time because it was the start of the worksheet. And like, okay, this is how you do it. This is what you do to solve it. So that's why, a couple of reasons why. Going just a little bit faster, maybe. Let me know in the comments below if you want me to go a little bit slower on a follow-up video, maybe, to explain this topic a little more. But we would be putting everything on one side. So 4 and 10 was the first thing that came to my mind, but that doesn't work. How about 5 and 8? Yeah, there we go. Because then I could make the 5 negative, the 8 positive, x equal to 0. So that means x is going to be equal to 5 or negative 8. And we have the same kind of thing happening where a negative solution won't work because a square root of a number cannot be equal to a negative, which x is right here on the other side. So that negative will not work out. So 5 is the only answer, right? And I don't think I've mentioned what that's called on this video yet. It's called extraneous, which means exactly what it sounds like, really, extra. It's an extra solution. It's extraneous. It's an extra solution. We don't need extra solutions. Sometimes it's good to have extra of something, but when it comes to extraneous solutions, those are unwanted extra things. Like if you had, let's say you had 2 dining tables. It's like you only really need 1 dining table, you know? Like you could maybe, get 2 sofas, stick them together, but 2 dining tables, I don't know. That'd be... So some things just don't make sense to have more than one of. And that's kind of what we're going for here. You can have any number of regular solutions and then any number of extraneous solutions, depending on how complicated the problem is, actually. So this would be plus n minus 90. That's going to be 9 and 10. Minus 9 plus 10. Right, so the solutions are 9 and negative 10. Negative 10 won't work, so 9 is the only answer. All right, still more of the same stuff, so that's why I'm blasting through these pretty quickly here. I'm going to also reverse the order so that it's in order. Not that it matters too much, because I'd have to be subtracting 17x and adding 70 on both sides. 7 and 10 looks like that's going to work for that one. We want minus minus. X is on both, which means we have 2 positive solutions. X is going to be equal to 7 or 10. And usually both would be fine. We could test it out. We could test the 10 out pretty easily, actually. 17 times 10 is 170. Minus 70 is 10. Square root of, is 100. Square root of 100 is 10. So the 10 works out. 7 is a little harder to check, but I would imagine that one would work out as well. I think that comes out to be, because that'd be 49, 7, 1, 7, 1, 1, 119 minus 70 would come out to be 49, and then that works as well. Okay. Now we get to a little bit of a different problem. So notice there's more than one thing on the other side. As long as the square root is by itself, then you can go ahead and square both sides. You can actually square both sides even with the square root not being by itself, but it won't get you anywhere. So, I mean, you can do whatever you want because, it's an equation. You can do whatever as long as you do it evenly to both sides. But if you want to solve the equation, then you're going to get closer to the answer by isolating the square root. It's already isolated, so that's not a huge deal. But, and I didn't mean to put an in there. I meant to put a 2. But since this is a quantity now, not just one thing, the whole thing is squared. The whole square root is squared as well. But I don't need to put parentheses on it because the square root is kind of also a parentheses because the bar extends over what's in parentheses, basically. So that goes like that. That cancels just like it normally does. But then this is the same thing as this. All right, do not distribute the square. A 2 will distribute into an n plus 3 if it's being multiplied, not if it's a power. You'll get part of the answer, so you wouldn't be that far off, but you would at least get, some partial credit. You wouldn't get full credit. because if I FOIL this out, I get first times the first is n squared. Then outer times the outer is 3n. Inner times the inner is 3n again. Last times the last is 9. So notice if I distribute the square, I get n squared and 9, just not the middle terms. Right? So then I'm going to go ahead and get everything equal to 0 already, because I know that I'm going to have to refactor this. So n squared, that's 6n minus 4n is 2n. Subtract 8 from 9, and I would get 1, positive 1. And this is actually going to be a square term. This would be n plus 1, n plus 1. So the only possible answer would be negative 1. Now, remember when I said negatives usually don't work, but they can work? This time we would actually want to plug it in to check. So if we plug in negative 1, 4 times negative 1 is negative 4, plus 8 is 4, square root of 4 is 2. So we get 2 on the left-hand side. On the right-hand side, we have n plus 3. If we plug in negative 1, we get negative 1 plus 3 is 2. So actually, negative 1 is not extraneous. That is a negative solution. That is a regular and good solution. Now for 22, it changes again because we don't have the square root isolated. If you don't have your square root isolated, if there's nothing else around it, you can go ahead and square. If there is, you have to kind of solve for the square root first. You have to solve for the square root first. Because if you don't, then you'd have to FOIL negative n plus root 6n plus 19. And then you'd end up with another radical after you square that. So isolate the radical, then square both sides. All right, so that's 6n plus 9. And this is always going to be n squared. And then notice how this was 6n over here. It's always going to be double the amount of letters as the other number. So double 2 is 4. So I have 4n, and then 2 squared is 4. All right, then we would set it equal to 0. So I'm going to come over here, 0 equal to n squared. I would subtract 6n on both sides, so minus 2n. And then subtract 9, so I get minus 5. Oh, that's weird. Oh, 19. Okay, that's why that's weird. Okay, I wrote 9, but it was 19. No wonder. Okay, so we'd be subtracting 19. I was like, wait, hold on, that's not going to factor. Because every other question has factored so far. I just forgot to put the 1. So subtracting 19 makes minus 15. There we go. That'll factor into 3 and 5. Minus 5 plus 3. So those are our two possible solutions. Negative 3 and positive 5. So then we would check both, see if they work, and I think they both do. Doesn't look like there'd be any issues. We're just going to go ahead and say they both do, just for sake of time, but we can check later. Just kind of trying to wrap up here. We've got 6 more. Wow. All right, we can speed run this thing. Let's do it. So we would subtract 4 on both sides, then square negative 3m plus 10 equals m squared minus 8m plus 16. So then we would add 3m to both sides, subtract 10, so we get 6 and 1. So we get 6 and negative 1 for our answers. And so what I'm going to do from here on out is I'm not going to check the extraneous solutions because I need to finish up here pretty soon. I'm on a little bit of a time crunch today. So for 22 and on, I won't keep saying it, but all the solutions are possible solutions that I'm boxing, and you would check for extraneous to see if there's any extraneous solutions. So x squared minus 10x plus 25, double the number for the middle term, square it for the last term. X plus 1. So then we get x squared minus 11x minus 24, no, plus 24 equals 0. That's going to be 3 and 8 minus minus. So we get 3 and 8 for our solutions for that one. All right, again for here, square, square. So we get n squared minus 14n plus 49 equal to 3n minus 21. in squared, we would subtract 3 in, and we would add 21, so that's going to be 70. So 7 and 10 minus minus, which means our answers are going to be 7 and 10. Over here, square, square, b squared minus 12b plus 36 equals 18 minus 3b. b squared, we would add 3b to both sides, subtract 18 from both sides, which actually that's going to be 18. 0. That's going to be 3 and 6 minus minus, so 3 and 6 are our answers there. Okay, and then the last two. So we would add 3 to both sides first, square both sides. M plus 59 equal to m squared plus 6m plus 9. 0 equal to m squared plus 5m minus 50. So that's 5 and 10. Positive 10 minus 5. So we get 5 and negative 10 for our possible answers for that one. And then last but not least, we would add a to both sides. So plus a to both sides. And then square it. Square it. 7a minus 54 is equal to 36 minus 12a plus a squared. Set it equal to 0. So then a squared, we'd rewrite it so that the a squared is in front. Subtract 7, so minus 19a. Add 54, so that's going to be 90. So that's 9 and 10. Minus minus, so our answers are going to be 9 and 10. And just like that. So it doesn't have to be too crazy. That's the speed run, and that's the second part. So, and you can see what some of the extraneous answers are here. But if this video was helpful, you can go check out other free resources at myersmathematics.com, and that link will be in the description. So go check that out. Oh, interestingly enough, 23 doesn't have any solutions, so both of them were extraneous for number 23. One extraneous for 24, one extraneous for 26 and 27. All right, so just keep that in mind for those, because remember, I didn't check for extraneous solutions starting from 22 on, just took too much time. But definitely, you can see from here, you got to check for those extraneous solutions because they will pop up. So definitely plug both back in. Either one of them could be extraneous. So yeah, go check out the other free resources on my website or other YouTube videos in the channel. The playlist for all the algebra worksheets will be popping up soon, as well as the my channel itself. You can subscribe, like, all that kind of stuff, and I'll see you guys in another episode real soon.